Welcome to all. This is part 11 for general public. That is of analysis of singly and doubly reinforced section by working stress method. And for the RCC batch, it is class number 20F, I think. Okay, that I will clarify there when I send the class link for them. Make a note, last time class 10, part 10. Actually, last class only it is over. This is an extension, means additional question. Purpose is to gain more knowledge and some extra information. Or you can tell, if this class you thoroughly understand and solve, everything will be clear. Part 1 to part 10, all will be clear. Reason I will tell. Okay. Practice question for gaining more knowledge and more grip and to improve your structural knowledge. Okay. Class, 2 questions are there in the class. When I put a class means something I am telling here, that you are right. There will be 2 questions. And both will be for doubly reinforced section. Reason. Singly, actually, I can do this, see, 1 dot and 2 dot. I can do once for singly reinforced, once for doubly reinforced. No, not required. Because if you cover doubly reinforced, automatically you are covering singly reinforced. Because why? What all terms are there in singly reinforced section, it repeats in doubly reinforced, but extra terms are there. So I decided for doubly reinforced. Question number in the today's class will be 1 dot, 2 dot. Remember, 1 dot, you should write this way. This 1 dot is equivalent to Roman 1 earlier. I told earlier. Lastly, I will tell Roman 1. Randomly apply a bending moment or any bending moment. See how much stresses will come. Strength, permissible stress, balanced, under reinforced, over reinforced, none of them will come. Apply the bending moment, find the stresses. Eat and pay. Whether you have money or not hardly matters. The hotel owner will not ask you, do you have enough money like that? Whatever you order, he will supply. Lastly, you will tell, pay the money. Suppose you tell, money is not there, it is your problem. Second question I am doing is equivalent to Roman 2. Remember, that is for finding MR. See, by name only you can make out. MR means strength counts. Before eating, check the money. So when you do for Roman 2 or MR question, permissible stress will come, under reinforced, over reinforced, all concept will come. That is told so many times earlier, so I will not once again tell now. See, remember earlier, but note, brief solution. When? Not here. When I go to stress calculation, that is as per Roman 1, or MR calculation, that is as per Roman 2, then brief solution. Simply I write the answer here. See, I already solved everything here. You cannot mean, if it is partially visible, not required, visible for me. As I told, to save the time, I prepared all these. 3 reasons. 1, saving of time. Second one, calculation mistake chance. When I hold the calculator here and calculate, sometime doubt will come. So, and last one, third reason, this is actually practice question for you. It is not a new concept. So it is sufficient if I give only answer. Therefore, these number you never bother. It is for my reference. Someone may tell, why not write in a paper and write? No, paper I don't write. Start. Write everything I explained in today's class. How you write? You go through the class in your own way, in your own language, write. Important points you write. In between, there is one not concept, something I will tell which you need not write. That is, people who outside, they make some mistakes. I will highlight that one. For that, I will give extra information later. See, now, question dictated in class. I will dictate the question. See, I will stand somewhere outside so that otherwise, when I explain, you may not be able to see. So I will go somewhere there, only voice required now. Okay, question. A rectangular section of a RC beam is 250 mm wide and 650 mm deep. It is reinforced on tension side by two bars of 20 mm diameter at effective cover of 50 mm and on compression side by two bars of 16 mm diameter at effective cover of 45 mm. Concrete is M20 and steel tar-op grade Fe415. The beam is simply supported for an effective span of 5 meters. And it is effective span of 5 meters. That's all. Now, that is question. Now still, now write, this much is common data. Right, make a note. Now put one line here. After this much, put one line, right? One dot. Find maximum compressive stress developed in concrete and maximum stress developed in tension steel for the entire beam if the beam is loaded by an UDL of 18 kN per meter in addition to self weight. That is question number 1. Okay. Question number 2. Remember, I told earlier up to where common. Question number 2. Find that 1 is gone now, 1 is over. 2. Find what maximum UDL, what maximum external UDL beam can support. What maximum external UDL beam can support. Question 1 I told what? Find the stresses, maximum compressive stress in concrete and maximum stress in tension steel if the beam is loaded by UDL of 18 kN per meter in addition to self weight. Second question, that is not there. New question. Find what maximum external UDL beam can support. Over. Start. First, solution for 1. Something in the class. Consider the beam with UDL. Say W per unit length. We will decide unit later. Span is 5 meter. Given UDL is 18 kN per meter in addition to self weight. Now, in addition to self weight means sometimes people get doubt, grammar problem. In the offline class, sometime I will ask. First time when they reach the stage in RCC, in addition to self weight means is it including self weight or excluding self weight? Answer. I will give two options for them. Option 1. In addition to self weight means self weight is not considered. It is an external UDL. So you have to calculate self weight and add to it and get the final UDL, total UDL. I will tell confidently. Or I will tell option 2. This also I will tell confidently. In addition to self weight means self weight is already added. That means when they tell UDL of 18 kN per meter in addition to self weight means self weight is already added. Therefore, that's all. You should not consider self weight. This way I will tell. Then I will tell them, okay, tell which is correct. Some will tell that is first one is correct. Some will tell second is correct. Confusion is there. Okay. Then finally, I will tell, okay, difference of opinion. Democratic country. Our India is a democratic country. Therefore, we will go for majority. Agreed? Yes. All will tell, yes, sir. Then I will tell, sorry. In my class, when a structural concept comes, majority does not count. Finally, what I tell now counts. That they know it actually. Okay. Therefore, I will tell, if you have any problem of this one, remember, you make a note here. In addition to self-weight means it is not including self-weight. I think those who know English, they can make out. Self-weight is to be added. Like someone will tell, what is the cost? Sir, 10,000 rupees in addition to taxes. Means taxes separately is there. Therefore, right here, that is in the class I told, that is 18 kN per meter is excluding self-weight. Excluding space is not there. I will put self-weight. Okay. Therefore, you have to find self-weight. Okay. Find self-weight. This I will not explain now because you are supposed to know. Self-weight equal to width of beam in meter 0.25, depth of beam in meter 0.65, length is not considered, into 1 because by unit length, into density of concrete, weight density, 25 kilonewton per meter cube, it will come 4.06 kilonewton per meter. Remember, the self weight is a UDL. Therefore, our question number 1 is what? Already UDL of 18 kN per meter given. Therefore, UDL on the beam W equal to 18 given UDL plus 4.06, 22.06 kilonewton per meter, including self weight. This is the W to be considered for any calculation. Okay, over. Now, class. What they want in question 1? Maximum stresses developed. Now see, when a cross-section of beam is subjected to a bending moment, see there, stresses will develop. You know expression for M. Easy to understand. As bending moment is, suppose you initially no bending moment, no stress. As the bending moment increases, stresses also will increase in both concrete and steel. So where the maximum stress will come? When maximum stress will be developed when you where for that cross section which is subjected to maximum bending moment. So all this you write here. Maximum stresses will be developed in cross section for which bending moment is maximum. Now, for simply supported beam with UDL over entire span, maximum BM will be for a cross section at center given by WL square by 8. You know it. W 22.06 into 5 square by 8 is 68.94 kilonewton meter. Okay. Now, sagging bending moment. Now, one important information. So many people, this I have told earlier in regular batch I tell, axial force, shear force, bending moment, twisting moment, all people tell internal. It is complete nonsense. For this, I will make a separate class in YouTube. I will start uploading a series of classes where I will highlight the blunders or mistakes committed. And my purpose is not, I will tell in the class, my purpose is not to insult you or degrade you, hurt you like that. When you are doing something wrong, I am giving you information so that you correct it. They should remember. So if they correct it and if everybody will correct that one, I will be very happy. My purpose is served. So it is not that somebody is making a mistake, make fun of them. That is called sadistic behavior. I am not a sadist. So therefore, I will upload later. See, people will tell when the cross section is subjected to bending moment, they are trapped there only. When it is subjected to bending moment means how it is internal. Internal is resisting moment. See, when you go to MR, it is a maximum bending moment cross section can resist by virtue of the internal couple. So, therefore, bending moment is not internal, it is external. I will give so many examples there. People who are telling it is internal, they will open their eyes, realize the mistake, at least they will change over to external. My purpose is served. Okay. Class, now, this much over. Now, class, some statement you are right. Our question is to find maximum stresses developed. For the entire beam, I told entire beam. Just now I told maximum stress will be developed where bending moment is maximum. Therefore, now our question 1 will reduce to, now our question 1 will reduce to, you should write here, reduce to finding the stresses developed, maximum stress in concrete in compression, FCBC, and stress in tension steel, FST, when it is subjected to bending moment of 68.94 kilonewton meter. Whatever stresses you are getting will be the maximum for the beam. Okay, write the statement. Now go there. Where means here. Come here. Don't see this one. Write the cross section. Okay, this all I told you. Tension side 2 of 20 torque, effective over 50, compression 2 of 16 torque, effective 45, B, D, AST, ASC, D dash, M20 concrete, sigma CBC. Actually for stresses developed, the strength is not required, but given data, write it. That will tell you, even if you write the sigma ST 415, you are not using it. IS code sigma CBC 7, steel 230, Required, there is no space to write here, so I wrote required to find maximum compressive stress developed in concrete, FCBC, and stress developed in steel in tension, FST, when the cross section is subjected to M of 68.94. See, I am not using the word maximum here because when you consider the cross section, concrete maximum stress, steel there is no maximum, but for the entire beam there is maximum. Okay, done, leave it. Now happily solve. Reference is Roman number 1. Now if you cannot solve, you class number 1 to class number 10 is fully wasted. Okay, now I will do one thing, simply I will write the answer. Solve. You require M. M will come 13.333. You require MC. MC will come 20. Then you require X value. 152.879 millimeter X will come. Okay, now use expression for M. Make a note here. Actually, again I am repeating. Balanced, under reinforced, over reinforced, permissible, none of them will come here. Your bending moment is 68.94. Find stresses. Okay, start. Write equation for M in terms of FCBC. But actually FC dash also will come. So using similar triangles, replace FC dash in terms of FCBC. That will come. These all already over 0.7056. Substituting your FCBC, maximum stress in concrete in compression, will come 5.1127 Newton per mm square. Then find FST, stress in tension steel. Use the relation MFCBC by FST equal to X divided by D minus X. FST will come 199.368 Newton per mm square. Okay, over. Therefore, I will rub everything now. I will write the conclusion here now. See, solution is over. See, solution for one dot is over. Okay, now full board rubbed out. Okay, imagine. But I am not rubbing out. I will do one thing now. I will rest right here, somewhere here. Conclusion. Okay. I will write conclusion here. Conclusion for one. For one dot. For the entire beam, maximum BM will be at center. And how much you can write here, which came M max equal to 68.94 kilonewton meter when the beam is loaded by external UDL of 18 kN per meter. And for this cross section, whatever stresses you are going to get is the maximum stresses. So for this you got FCBC, you write here, maximum compressive stress in concrete, FCBC max, not max permissible, max equal to 5.1127. You should write statement solve, not this way, Newton per mm square. And the maximum stress in tension steel for entire beam, we got FST maximum for entire beam 199.368 Newton per mm square. Over. Solution is over. Okay, now, by chance, someone will ask you, with this information, can you tell beam is safe or not? You can tell, yes. Compare. Concrete gets a stress of 5.1127. Limit is 7. Oh, concrete is safe. Steel stress is, tension steel stress, 199.368. Limit is 230. Therefore, that also is safe. But one thing you can make out, extra information I will tell you, the last end of the class I will tell, not now. Okay, over. So if they want, this is your part 1. First part. Now, solution for second one. Remember, first something in the class I am telling. Class. You should write it. So this all will be removed now. So everything will be removed now, removing now. Because why? This all will gone now. Okay. Full gone. This is gone. This is also gone. Yes, this is also over. That is gone. Okay, now start fresh. What all I tell you, right? Solution second section, second part, they want what is the maximum external UDL beam can support. Oh, they are asking maximum you can apply. Now strength will come. So what you do is, right here, let to find, but no, find is already not required. Why? Already told. Okay, leave it. Or you can write here, you write. Now second part, second question, we have to find maximum external UDL beam can support. Okay, now some more side here. Let once again W be intensity of UDL, or like right here, let W be maximum intensity of UDL. That is, the beam can support. Maximum important, beam can support. Now, but remember, including self weight. Self weight you see later. Including self weight. Okay, now calculate what? Put the beam. Span is, this is one more thing, self weight in unit kilonewton per meter. So this is W is in kilonewton per meter. Now your L should be in meter, L equal to 5 meter. Okay. Now right here, suppose you draw bending moment diagram for this one, BMD will come this way. The maximum BM will be at center given by WL square by 8. See, different sections will have different bending moment. Now, they want to find the maximum UDL beam can support, means the beam should be safe everywhere. For this BM also it should be safe. So, when different sections have different bending moment, beam will be safe if it is safe for the maximum BM. This all you are right. Therefore, to find the maximum loading here, what you have to do is, so for getting maximum permissible value of W, consider maximum bending moment, which is for cross section at center and is equal to right, WL square by 8. That is W is unknown. W into 5 square by 8 kilonewton meter, sagging, tension, compression. Okay, now this much over. Now one more statement. How to find it? See, for safety, for any cross section, right here, for safety, for any cross section of a beam, bending moment is what you are applying. Moment of resistance is how much maximum it can resist. So you can tell very easily, bending moment for cross section should not exceed, red color I will put, it should not exceed danger number maximum bending moment. Or sorry, not maximum bending moment, exceed bending moment for cross section should not exceed bending moment for cross section. Therefore, consider maximum BM. See, this is the red color I will tell, maximum BM. This red is for danger. Okay. Maximum BM. And equate maximum BM to what? Usually I ask in the class, to what? To moment of resistance of cross section. See, suppose I will tell you, bending moment is, for this question, See, I will tell you for this question, your MR is going to be, MR 79.53. Okay, leave it now. 53. Okay, leave it now. Later, suppose bending moment is 60. It is less than 79.53. You are applying a bending moment of 60, but cross section can resist maximum 79.53. Safe, no doubt. But what load produces a bending moment of 60 is safe, but it is not the maximum load. So the critical load will be when the bending moment maximum becomes exactly equal to MR, or when the money in your pocket exactly becomes equal to the bill. Okay, so equation. Therefore, maximum BM to MR of the cross section. Now see. Now already you got maximum BM. It is here. Now to get what? Therefore, now we have to find moment of resistance of cross section. Okay, now write here. That is, remember, equivalent to your Roman 2. Moment, see, moment of, one note you write here, one note. Moment of resistance. Therefore, under reinforced, over reinforced, balance, etc. and also permissible stress, all will come. That I told so many times. Refer earlier question to it. Okay, now leave it. Start. Now go for calculation of MR. That is, I told, that will be brief solution. See, calculation of MR for cross section. Now what I will do is go there. I will tell you go there. Go there. Where? Go there means here. Once again write good for health. You come will tell, sir, already, no, make independent question. Write all these details and proceed further as per MR calculation. So, now I should not explain. You will get X equal to 152.879 millimeter, X over, then write the equation for MR, where equation, okay, I'll put here. Now write equation for MR. When you write that way, FCBC max permissible will come, and also further one FC dash will come. Okay, start. Correctly get FCBC max, get this. First get this. Get this. How means, don't ask me. How many questions over, how many times I told, for that one you require red color, you require K, 0.289. Then you require XC, depth of critical neutral axis. It is somewhere 199.368. I doubt. No. It is, I can make out, it's wrong. Some other number. It is 173.4. Your X, which you got how much? 152.879 millimeter is less than XC. Cross section becomes under reinforced section. Again, I should not waste time. Under reinforced section, weakness is on tension side. Therefore, stress in steel will first reach critical limit. So, your stress in steel, FST, will reach sigma ST. But at that time, FCBC will be less than sigma CBC. Therefore, to get, but we want what? We want FCBC max permissible. Okay, get it. How to get it? I told, consider FST equal to sigma ST, substitute. First of all, already over. You will get the answer. First of all, this much also I should not tell. 5.8982. 5.8982 Newton per mm square will come. FCBC. Now, you require FC dash. Use similar triangles and get FC dash 4.1621. 1621 Newton per mm square. With all this data, you calculate. I think space problem is there. I can rub here. Okay, I can rub here. with all this data, calculate further, come this side, moment of resistance of cross section. It will come, how much I told? 79.53. 79.53 kilonewton meter. Okay, now MR, kilonewton meter, it will come, actually first it will come in 10 to the power 6 Newton millimeter, but we want kilonewton meter. Why? Because our bending moment is in terms of kilonewton meter. I rubbed it now. So now, equate, I rubbed it, maximum BM to MR of the cross section. Maximum BM is W into, I rubbed it actually, it was there, 5 square by 8 equal to 79.53 equate, you get the value of W. W equal to, how much you get? 25.45. 25.45 kilonewton per meter. It is including self weight. Including self weight. This is the maximum permissible UDL for beam including self weight. Okay, but right here. But they want what is the external UDL. Anybody can do it now. I can remove all this one now. Now nothing is there. I'll remove here only. Nothing required now. Now do one thing. Now find self weight. I already told self weight how to calculate. Calculate, it will come to 4.06. Correct, 4.06? I forgot. Check the answer, safer side. 0.6 into 25 divided by 8 is, calculate is not on. 22.06 divided by 8. That bending moment correct? Correct. Okay, now 4.06, 0.25 into 0.65 into 25. That's 4.06. So, including self weight, beam can support 25.45. This much self weight is there. Therefore, maximum external UDL, beam can support equal to, remember, beam is not resisting the load, it is supporting the load. It is not resisting the load. This all I will tell in the extra classes. This is also mistake. How much? 25.45. Subtract 4.06. It will come. I noted down 21.39 kilonewton per meter. See, that is, if you apply, now you can go backwards. If you apply external UDL of 21.39 kilonewton per meter, with self weight, it will become 25.45 kilonewton per meter. Will produce a bending moment maximum of 79.53 kilonewton meter, which is exactly equal to MR of the cross section. So, this is a maximum load permitted. So, now class over, that is part number 11 over. Now, one small information. If possible, you think, otherwise leave it. By chance, so I am solving this question. Somebody gives this question to me, maybe an interview like that. He will first ask me, I am applying a UDL of 18 kilonewton per meter, and please tell me, he may not ask me, tell me please, he may order me, tell what is the maximum stress in concrete, in compression, and stress in steel in tension. Okay, I will tell him, give me a small paper. I don't have to write everything. Calculate required. I will finally tell him answer. Stress, maximum stress in concrete, 5.1127. FST maximum, 199.368. Okay, he told, yes, correct. Maybe he has got solution. Then he will ask me, see, I told you, beam is loaded by external UDL of 18 kN per meter. Can you tell me what is the maximum UDL beam can support? Yes, calculate. Okay, I will tell them. See, I will do something like this and tell. Including self weight, 25.45, excluding self weight outside, 21.39. He may ask me, how you got it? I got it. No, you have done something wrong. Unless you find moment of resistance, you cannot calculate. I will tell I can calculate. How? Okay, I will tell him. stress in concrete, see correctly, 5.1127. That is actually, if you compare, it is 5.1127 divided by 7. It is 73.00385% of the limit of sigma CBC. Okay. Stress in steel we got 199.368 divided by 230. It is, this is, stress in steel is 86.68173%. He will tell, so what? That means linear variation, working stress method. See, this 80 stress in steel already reached 80%, 86% of the limit, but concrete reached only 73%. This clearly will tell it is under reinforced section. Oh, is it that way? Yes. Okay. But still tell me, how you got this number? No problem. I will do one thing. 86.68173%, I will take reciprocal in decimal. Reciprocal decimal. I will not use 86, 0.866. I will take reciprocal. I got 1.15364 means it has got further 15.3645% more strength. I will multiply that one with your earlier UDL of how much? Including self-weight, earlier UDL of 22.06. I will tell, I will multiply with 22.06. I got 25.45. Oh, that way you can do it? Yes. If you know the concept, you can do that way. Suppose I want MR, no problem. Same percent. What? I told this is 199.368 divided by 230%. 0.86 is without 100. I will take reciprocal. I will multiply with what BM you got last time. How much? 68.94. Multiply by 68.94. I will tell, you take the calculator, you only put equal, see how much answer you are getting. He will take my calculator and tell 79.53. Yes, that is the MR. That is the MR. If he knows the concept, he will appreciate. If he does not know all this concept, he will regard you very high. He will tell you really know subject. So remember, structures is not only by hearting and what you call is by hearting the formula and solving problem. Understanding. Once you get the understanding, you can do miracles. Okay. Now this is just to give you confidence, those who are interested. Otherwise, all you, when I get this answer, you stop and go to next question. Go to next class. Okay, over. Thank you. We will meet in next class where I'll upload design of shear reinforcement. Okay.